Good evening, everybody. I hope you are all having a good evening. Tonight's lesson, changing to vertex form. Well, we are now in the quadratics unit. So if you'll take a look at number 1, this is standard form. If you'll recall standard form, y equals ax squared plus bx plus c. And this is the form your calculator gives you when you plug the points in and do a quadratic regression. It gives you the standard form. Well, standard form gives you some information about the parabola. Number 1, it tells you if there's a vertical stretch or vertical compression, because here we have the a value. It also tells us what the y-intercept is. What is that y-intercept? Also, if the a value is negative, it tells us that it opens down, that the parabola opens down. If the a value is positive, it opens up. Now, what we want to do here is we want to change to vertex form. Vertex form looks like this. Y equals a times the quantity x minus h squared plus k. Now, why is that helpful? Well, again, each form tells us something different about the parabola. Vertex form tells us something about the vertex. If you recall, h comma k represents the vertex of the parabola. So if you are given an equation in standard form and I was to ask you what is the vertex of this parabola, you would need to change it to vertex form. Okay, so let's do that. In order to change this to vertex form, we need to use a method called completing the square. So we're going to make a perfect square. Remember what a perfect square looks like. 25 is a perfect square. Remember why? Because 5 squared is 25. Okay? X squared is a perfect square. Why? Because x times x is x squared. X plus 3 squared. That's a perfect square because x plus 3 times x plus 3 is x plus 3 squared. Now remember, this does have something to do with the square. If I was to draw a square, we know that the sides are the same. So in order to have a perfect square, the sides would need to be the same. So in this case, for number 25, it would be 5 by 5. 5 by 5 make 25 as the area of our square. Same thing here. This would, in order for this to be a perfect square, we would have x times x. And then here again, we would have x plus 3 times x plus 3. Anytime you have something that's multiplied times itself, you have a perfect square. All right, so we want a perfect square here. Notice in the vertex form, we have a perfect square located right here. And so that's what we want to get here. So to complete the square, first step, step number 1, rewrite the problem, leaving a blank after the middle term. Move that plus 1 over, and then make another blank. So that's step 1. All right, step 2, let's rewrite it again. And since our a value is 1, we can go straight to this form right here. Because since our a value is 1, a is 1. So a is 1. I don't have to write it, but I'll write it anyway. Okay, so changing forms. So x. Now, in order to get this value, the h value, we take half of b. So in order to get this value right here, half of 4 is 2. Okay, completing the form. Okay, parentheses, squared. Now, in order to get our k value on the end, we have to fill in these blanks up here. So to fill in the blanks, first we took half of 4, which is 2, and then we square that number. So 2 squared is 4. So we add 4. So we added 4 to the right. So in order to keep this balanced, say we added 4 apples. All right, we'd have to subtract 4 apples in order to make it balanced. So we have to subtract 4. These two should cancel each other out. But notice we needed the plus 4 in order to make a perfect square. So then finally we have 1 minus 4, which is minus 3. Now for all of these problems, I want you to write down the vertex. So the vertex is going to be our h value, which remember is the opposite. This is 2 units to the left and 3 units down. So our vertex got moved 2 to the left, 3 down, and this is our vertex. Okay, so that's the answer to number 1 for your worksheet today. Okay, a couple things. Number 1, the word in the circle is circle. Make sure you put that down on your notes, please. To check your work, notice it says show some work. So this is the work I expect you to show. Also, it says only use your graphing calculator to check. Well, how do we do that? How do we check that we have changed forms? So what you do is you plug in the standard form in for y1, and then you plug in your vertex form that you got into y2, and make that one thicker. If you arrow up and you arrow over and you press enter, you can get your thick line. Okay? So now watch when you graph. Let me change it because it's not going to work unless I change something. Okay, here we go. So here's the first one. Here's the second one. Remember, they're the same. I did not change the parabola, the quadratic. I did not change it. I just changed its form. Okay? All right. Next problem. Remember, you're doing this on your own sheet of paper. Let's look at number 15. Something else to keep in mind. When you're looking at the equation, look at the numbers. Can I factor anything out of all 3 of these numbers? Can I simplify this at all? No. Okay. Look at number 13. Can I factor anything out of these 3 numbers? Yes. I would factor out, if I was a student, I would factor out a -3 to make my x squared positive. I want my x squared to be positive. Factoring out a -3, remember factoring is the same as dividing. So we're going to have -2x, -3 goes into -3, +1 times. So what we have right here is we have our a value. And we would complete the square with what's left over. Okay? Using the same process we did on the front for number 1. Okay, let's take a look at number 15. We can't factor anything out of these 3 numbers. So, what we're going to do is we're going to rewrite it just like before, leave a blank, move that 3 over, and put another blank. Okay, continuing on. Now, we need to factor out a 2 out of these first 2 terms. Don't mind the 3, just these first two terms. So factoring out a 2, 2 goes into 2 once, 2 goes into 12 6 times, leaving our space. This time I'm going to close this up because I want the 3 to be outside. This is a whole different deal. So the 3 is on the outside. Now we complete the square. So I'm going to go ahead and change forms here. So I'm going to do x. How do I get h? Do you remember? What do I do with b? Let's write it over here so we have it down. We take half of b. Remember, this is our b value. Half of 6 is 3. Okay, now we got to go back up. So pay close attention. 3 squared is 9. Pay close attention. Don't fall asleep. Pay close attention. We got to take and factor that 2 back in. So we have to multiply the 9 times the 2. 9 times 2 is 18. Go up one more level. Okay, this is the number that we subtract to cancel, to keep it balanced, keep our equal sign, keep it balanced. Subtract 18, goes down here. 3 minus 18, negative 15. What's our vertex? What's our vertex? I think I'll save that for the video quiz. What is that vertex? Things that make you go, If you can't remember how to get the vertex, look back at that previous problem that we did. See you in class tomorrow. Have a good night.